Imagine an elevator, but instead of going to the 20th floor, it goes to space. Wild idea, right? But is a space elevator real engineering or just sci-fi fantasy?
Behind every moment lies a scientific wonder. I'm Kale, and welcome to SciCurios, where curiosity meets science.
Scientists have dreamed about this for over a century. A giant tether stretching 36,000 kilometers into the sky, letting us climb into orbit like it's no big deal. This isn't a random idea. NASA, JAXA, and the International Academy of Astronautics have all studied it. Here's the concept in simple terms. Anchor a super strong ribbon to Earth. Stretch it past geostationary orbit, where satellites hover over the same spot. Attach a counterweight at the end so centrifugal force keeps the whole thing taut. Then send robotic climbers up and down the ribbon, carrying cargo to space using electricity instead of rockets. NASA's Advanced Space Transportation Program describes this as one of the most efficient ways to reach orbit. Right now, getting anything into space is like paying for first-class tickets for boxes. Rockets burn insane amounts of fuel, shake like angry volcanoes, and cost tens of thousands of dollars per kilogram. A space elevator? In theory, it could bring that cost down by 95%. No fuel, no explosions, just electricity. According to NIAC research by Dr. Bradley Edwards in 2003, the energy cost could drop to just a few dollars per kilogram. But here's where the fantasy part creeps in. The tether needs to be incredibly strong, like stronger than anything humans have ever built. Carbon nanotubes and graphene come close, on paper, but in the real world, they never exist perfectly. Tiny defects weaken them dramatically. As studies in Acta, Astronautica, and NASA's NIAC reports show, our current materials are still at least 50% too weak for a full-scale elevator. Think of trying to climb a rope made of spaghetti strands glued together. The tether must pass through hurricanes, lightning, jet streams, and then face space junk and micrometeoroids. A single collision at 20,000 kilometers per hour? Ribbon goes poof. A 2007 analysis in Current Science noted that oscillations from wind, Coriolis forces, or even the moon's gravity could shake the whole structure like a cosmic jump rope. Another challenge is energy. The climbers might use lasers beamed from the ground to power their ascent. This works in small tests. NASA demonstrated it in the early 2000s. But scaling it to lift multi-ton payloads, continuously, safely. Let's just say it's like trying to charge your phone from across the city using a flashlight. Experts tend to agree. A space elevator is not impossible according to the laws of physics. But with today's technology, definitely not happening yet. We need breakthroughs in materials science, orbital infrastructure, and debris management. Many researchers, including the IAA study group in 2013, estimate we're still several decades away, if it ever becomes practical. So is the space elevator humanity's future highway to the stars, or a beautiful sci-fi dream? Would you ride a 36,000-kilometer elevator into orbit? Tell me in the comments.
Science is everywhere if you just know where to look. Thanks for watching SciCurious. Until next time.